Oh, there we go. Lovely. Let's turn that on. Excellent. We'll get the book up, and we will roll. Okay, chapter 2, variables, basic types. What the shit? Oh, this is interesting. Okay. So, welcome to the thing. I guess we'll make a new project. Empty project, yes. Empty project, C++. Next. I don't know. Chapter 2. Miscellany? I feel like that's been spelled horribly wrong. Miscellany? That's just chapter 2 will be fine. Where's my mouse? What the shit? Okay. My trial license will expire in 2 days. Yeah, okay. I guess I'll deal with that. I don't think I had a trial license there, buddy. Yes, thank you. This is... Wait. What? Whatever. So, is standard io.h better or worse than IOStream? Yo, dog, I can't even fucking spell today. Oops. So welcome to chapter 2 of the C++ primer, where I'm going through the C++ primer book. Chapter by chapter. There's 1,300 pages to this book, I believe. And yeah. So we're going to have a look at the fundamental basic building blocks of C++. Part 1, the basics. Chapter 2, variables and basics. Wait, what was Part 1, Chapter 2? Part 1, Chapter 1? It's what we did before, right? We built that weird ISBN scanner program, which took ISBN input and output a file, output to the console the total amount of Wonga achieved, basically. which was good. All went fairly smoothly. Disk space available 486 gigabyte. Okay. Thought I had less. I was starting to worry, but it seems we're all good. So, part 1, chapter 2. Oh my god, sorry. Variables, basic types. We're going to be covering the building blocks of C, basically. Chapter 1, I guess, got us into writing programs. Chapter 2 is going to refresh us. So the first primitive built-in type is an arithmetic type. Okay, no. That includes the arithmetic type and the type name void. Arithmetic types represent characters, integers, booleans, floating point numbers. Void type has no associated values, can be used in only a few circumstances, most commonly as the return type of functions that do not return a value. Cool. Like main, or I guess a function if you wrote a function that doesn't have any error codes. Seems a bit weird to do that, but if that's what you're doing, it's fine. So we got the C name here, bool, char, wchar, t. Let's write these. Let's write these. Thank you. Scrolly boy. Let's prop this boy up. Get the table in view of myself. And we can have, so we've got bool, char, which I know about. Then we've got wchar t. It's a wide character. Okay, cool. Char 16t, which is Unicode. Char 32t, 32-bit. Don't know about these. Short, I had heard of, which is a short integer, which can be the same size as an int, or it can be half the size of an int, depending on the bit depth of your operating system. Let's just get that microphone in the old. Yeah. Int long is 64 bits. So it's two longs stuck together. The minimum size. Okay. So there is no minimum size for a bool. A bool is a single byte, either an I or an O. I'm guessing. Or maybe it's 2 bytes. Maybe it's 16 bytes. Maybe it's not bytes. Maybe it's bits. Maybe it's 1 bit. Bool is type represents true or false. 0 character types. No, okay. Doesn't tell. Does not tell. A long float double long double extended precision floating point. So a float has a minimum size of 6 significant digits, which means the size of a float is determined when it's initialized, I guess, because even if you have 6 significant digits, there can be insignificant digits, powers of 10, etc., right? Just zeros at the end, but you'll need to know how many of those zeros you have. Also, I've never needed to know, but I don't know, and I don't know if you would know how to do this, but when you call a float, you can, obviously it says the minimum size is 6 significant digits, but could you call a float and specify the number of significant digits it can have? Interesting. I wonder. Here we go. Char. It's fine. Same size as a single machine byte. Yep, 8 bits. Or, oh no. Char is guaranteed to be read of all numeric values corresponding to its the characters, the machine's basic characters. Char. So a single machine byte is going to be 8 bits. And that's how we define the ASCII characters. But char T, char 16T, char 32 used for extended character sets. Finally, I have an answer on how extended character sets work. The Bachar T type is guaranteed to be large enough to hold any character in the machine's largest extended character set. The types char 16T and char 32T are intended for Unicode characters. Unicode is the standard for representing characters used in essentially any natural language. Oh, interesting. Oh. Remaining integral types represent integer values. Yeah. Int, short, long. An int will be at least as large as a short, a long at least as large as an int, and a long at least as large as a long. So they could all be the same size. The long was introduced by the new standard. Cool. Uh-oh, no, I've got to read this one. Machine level representation of the built-in types. Follow along. Page 61. Such as basic unit of storage, usually a small number of bytes, is referred to as a word. Smallest chunk of addressable memory is referred to as a byte. Basic unit of storage made up of bytes. And a byte itself is made up of bits. Word of memory as follows. 6, 7, 8 bits of each byte, and then there are 4 bytes in the word, and the memory addresses are there. We can use units to refer to several collections of bits. Starting at the address, speak to the word address or the byte address. It's cool. Okay, I didn't really need to read that, but it was good. This might be a short stream, which is good because it is midnight very soon. What was that noise? I don't even have my headset on now. That must have been quiet. Welcome to the Mouth Noise stream. Except for bool, extended character types, the integral types may be signed or unsigned. So a signed takes up an extra byte of information, or bit, a byte, a bit. I can't remember, but it adds whether or not it's negative or positive. So you have a factor of 2 more possibilities on an unsigned byte. An unsigned thing because it's not signed. Here we go. In an unsigned type, all the bits represent the value. For example, an 8-bit unsigned char can hold the values from 0 to 255. Yeah, an assigned char is guaranteed to be able to hold all the values from negative 127 to 127. Most modern machines use representations that allow values from minus 128 through to 127. Weird. You see, the span of the values is the same, but the maximum size of the values is half, because you've lost an order of 2. And, yeah. Because it's binary, it uses an order of 2. It's a little bit. When you do maths for so long, and you do like 2 weeks about different bases, and nothing ever again, and it was the hardest thing you ever learned. I still hate that. I don't even know, like I always went the long way around doing bases. I didn't come up on the exam, so I was clean sailing. But at the same time, it was always a fucking nightmare to do. Advice deciding which type to use, thank you. That's, what are the differences between int long, 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 and short? Between an unsigned and assigned type? Between a float and a double? Okay, so, an int has to be at least as long as a short. But a short can be as small as half a word on the operating on the system that you have it on. A long has to be at least as big as an int, but can be up to twice the size of an int. And a long has to be at least the size of a long, but has the potential to store, again, twice as much as a long. Float and a double, again, it's the same thing. A double has to be at least as big as a float, but a double has the potential to hold twice as much information, twice as many digits precision. In fact, the table at the top said that a float's minimum size had to be 6 significant figures, and a double had to be 10. So, and a long double had to be 10 as well. But again, it's more bytes per information, which means you can have more information in a long than you can in a short. Also, operating systems are optimized to read or understand the different basic mathematic stuff differently. So modern machines might be more inclined to read a long than an int, or an int than a short, and they're more inclined to read a double than a float, and a float than a... Sure, there was like a different, like a small float. Anyway, I remember reading that in the audio programming for C++ book, which I bought from the Humble Bundle. It's a very interesting book, but I got to a point in it where just reading it wasn't enough to absorb the knowledge, if you know what I mean. The type of the object defines the data the object might contain. Operators can perform, and the operators, many types, support the ability to convert objects of the given type to other related types. Yeah. Bool b equals 42. B is true. Yeah. Int I equals b. I has the value of 1. Yes. I equals 3.14. I has value 3. Double pi equals I. Pi has value 3.0. Okay. Yes, this is stupid code. Signed char C2 equals 256. Assuming 8-bit chars, the value of C2 is undefined. Unsigned char C equals 1. Assuming 8-bit chars, C has the value 255. There's some funkiness going on there. So if we step through this, I should write it for you. Sure. So the first thing when doing conversions from type to another type is you have to be the biggest stupid here is the I equals 3.14. Okay, so bool b equals 42. C has it that any non-zero value for a bool is true. So if the bool equals 0 or the bool equals null, to my knowledge, the bool will be true. So if you set your bool to 42, that's fine. Going in, it means true to the bool, but as we see from the example code, the bool is stored as a 1. Thank you. Thank you. The bool is stored as a 1 because it's true, and that's the easiest integer value for it to deal with. Also because a bool is a very small, a very small piece of data. Anyway, the int I equals b, we are initializing an int I to the value of bool b because bool is true. It doesn't deal with numerical input, it deals with yes or no. It sets I to 1, which is true. To it, not to us, obviously. Understanding this is what we're stepping through here. And then this is just stupid. This is user error, I would say, in my opinion. It's I equals 3.14. Obviously I has been initialized as an integer. I equals 3.14. I didn't know that it would truncate, but it does. It truncates. According to the example text, it says I has a value of 3. Then double pi equals I. We're initializing a double and we're setting it to the value of I, which is 3. And because it's a double, we'll have a decimal place. That's fine. Because it was initialized as an integer, we cannot get the precision that we once had back. Unsigned char equals -1. If you have an 8-bit char set, apparently that will equal 255. I don't know why. You tell me. Signed char C2 equals 256. This is undefined, and that is because it's a signed char, so the biggest it could be is 127. If you put a value above 127, it will not. feel like I'm doing something wrong here. Stop me if I am. Get off my screen, please. I want to. Thank you. Aye. I wish it would like wait for me to finish writing stuff before it was like, no, you've done it wrong. I did it again. What's wrong with C? Why is it there? So just get that up on a console thing so there's something to look at. Be nice and fun. Do we need a... Let's just quickly throw some of these in. Oop. I don't think I've done anything wrong or stupid. I should just spread things out on a line. We've got a couple of texty boys going on. Thank you. Are you doing it? Did you compile my shit? You didn't. Thank you. B as a 1. Yeah. 1, 3, 3, asterisk. Got some shit going on here though. Let's I see yellow. Is that just unsaved, or is that Jesus? Or is that actual warning? I don't want to be an actual warning. But there's some funky stuff going on here. I just want to see what happens. You know. I just want to see what happens, you know. And when we've got a tag, we've got some text next to it. It's easier to see, you know. It's all saved, it's all checked. Visual Studio says it's all good. We'll open it in the debugger. Here we go. That's actually a really good question. What is the Unicode? What is the ASCII character for number 255? Is it a space? I hope it's a space because nothing's showing up. But yeah, here we go. We've got our output. So B is 1, that's fine. I is 1, that's fine. I is 3, that's fine. It does truncate. Pi is 3. You'll notice how on the output it hasn't included. What is in my pocket? USB-C cable. Oh, itchy. The connector was digging into my leg. Sorry. You'll notice it has not included any decimal point. Interesting. C is something, I'm sure. Thank you. It could be a space, or it could have fucked up. C2 is or an x86, so that should be fine. C is undefined, and then C2 is asterisk. Okay, so that's cool. What happens depends on the range of values we permit. Here we go, here's what we're talking about. We assign one of the non-bool arithmetic types to a bool object, the result is false if the value is 0 and true otherwise. Good. When we assign a bool to one of the arithmetic types, the resulting value is 1 if the bool is true and 0 if the bool is false. Very important that we learn this one, as we've seen doing some of the Unreal Engine stuff. Comes up a lot when you have to test. When you have to test if stuff has happened, and you get a bool branch going on, and then 1 is yes and 0 is no, and it's, you gotta. It's good to know. Floating point value of an object of an integral type. The value is truncated. The value that is stored in the part before the decimal point. Good. When we assign it, so that's a really efficient way, I guess, to truncate some stuff in C++. That's how I remember having to use the trunc function in C, and that was just always so stupid. If you assign an out of range value to an object of unsigned type, the result is the remainder of the value modulo the number of values the target type can hold. For example, an 8-bit unsigned char can hold values from 0 to 255, inclusive of unsigned value. Outside this range, the compiler assigns the remainder of that value modulo 256. Therefore, assigning -1 to an 8-bit unsigned char gives that object the value 255. Oh, okay, that is interesting. If we assign an out of range value to an object of assigned type, the result is undefined. The program might appear to work, it might crash, or it might produce garbage resource. Cool. So we've learned some stuff there already. We've only been doing this for half an hour. Compiler applies the same type conversions. Oh wow. Expressions with unsigned types. Unsigned u equals 10, int I equals -42, standard console out, I plus I prints -84, cout u plus I if 32-bit prints 4294967 264. Right, so this does remember the same thing. So an unsigned int, a natural bare unsigned int in a 32-bit world will have 2 to the 32 values, which is that right? I gotta check now. Does this have to the power? Has square, okay. That's 1 over x. For fuck's sake. Scientific. Oh. Yeah, just scientific. 2 to the power 32? Yeah. So it's that 4,294,967,296 values. And so, as we learned in our previous lesson, if you step through an unsigned int to a point which is outside of its range, it moves to the position which is the modulo of that. So in this case, we have an unsigned int u, which is 10, and then we have an int I is minus 42. And the output will be the unsigned value of 10 minus 42 positions. So we go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then it goes to 4294967 and steps back 32 places, which is 4294967 We're learning. This is interesting stuff. So in the second expression, u plus I, where u is an unsigned int and I is an int, the int value I is converted to unsigned before the addition is done. Converting a negative number to unsigned behaves exactly as if we attempted to assign a negative value to an unsigned object. Value wraps around as described above. Regardless of one or both operands are unsigned, if we subtract a value from an unsigned, we must be sure that the result cannot be negative. Okay, so if you're doing anything, if you're doing anything with unsigned ints, if you go critical, it will loop. That is very important information. We've got a calculator on screen there. Enjoy that. It's really crazy how Windows comes with a scientific calculator as standard these days, but Android, you still got to download one from the App Store. Wild. Unsigned U42, U210, U1 minus U2. Okay, result is 32, it's fine. 42 minus 10 is 32. And then U2 minus U1, so 10 minus 42 will be the same as previously because it will wrap around. The fact that an unsigned cannot be less than 0 also affects how we write loops. For example, in the exercises, if you were to use the decrement operator to print the numbers from 10 down to 0, the loop you wrote probably looks something like this. For an I, 10 I is greater than or equal to 0, minus II, minus I, standard console out, I, standard line. You might think we could rewrite this loop using an unsigned. After all, we don't plan to print negative numbers. However, the simple change in type means that the loop will never terminate. Oh, I see. Oh, sorry. Smack the mic there real hard. That's cool because okay, so we're printing from 10 to 0. That's why it doesn't work. If you're printing 10 to 1, it would be fine. Because then you could have u is greater than 0. Right? No. Because when it goes, wait, no, yeah, you could do that because it can be 0, but it can't be less than 0. So when it goes down to 0, it would stop if it was just greater than 0. We only ever use the greater than or equal to, or less than or equal to, in C++ because it was like a catch-all or something in your program skipped a line of code or something like that would never happen, and it just moved on and did another operation and went to a negative value. Like if it was like, well, when this equals 0, you got to stop, but it would never equal 0 because you skipped 0 by accident. You didn't notice it because your program was garbage. I see. I think these streams are very unvisual. I think it's sad, but I'm putting them out there. I was completely random, I know, on the side note, but I get why people don't turn up for this segment. But don't worry, Unreal soon. Consider what happens for u on 0 on that iteration. Print 0 and then execute the expression for the loop for an unsigned value. So that'll be an infinite loop that counts from 10 down to 0 and then from 4.2 bil down to 0. Cool. Unsigned u equals 11. Start the loop 1 past the first element we want to print. U, while u is greater than 0, here we go. Minus minus u, standard C out u, standard line. Yeah, so he's fixed it. Caution, don't mix signed with unsigned types. Expressions that mix signed and unsigned values can yield surprising results, we've seen. Thank you. I will take due caution and diligence. What output will the following code produce? Unsigned u 10 equal u2 42, u2 minus 10, u2 minus u, sorry, is going to output 32, and u minus u2 is going to output 4,294,967,264. In I equals 10, I2 equals 42, I2 minus I is 32, I minus I2 is negative 32. Fine. Standard C out I minus U. 10 minus 10 is 0. U minus I. Also 0. Good. We could try that actually, because we haven't seen a good boy do a loop yet. Need to put it here. We already have I. Ooh. Can I reinitialize it using in I? I don't want to risk it. What the hell? Did you just see me write that? Can we just combine this all into one long? That's not going to work, is it? I know this isn't going to work because that pushes the right buffer, right? Wundle. It's later, right? He didn't say it was wrong, but pretty sure that's gonna throw a hissy fit. It didn't. There you go. Beautiful. 32, 429, 496, 7264, as I said. 32, negative 32, 0, 0. Beautiful. That is absolutely fantastic. I feel like I've grown in my understanding. Today has been the day of the unsigned int. I nominate today, 4th of February, the day of the unsigned int. Feels good. Okay. Bring that calculator back. Cool. Oh! Yes. What a waste of 2 minutes that was. Write a program to check whether your predictions were correct. If not, study the section until you understand what the problem is. Well, gentle friends, we've done that. Value such as 42 is known as a literal because its value self-evident. What? Every literal has a type. The form and value of a literal determine its type. What? A value such as 42 is known as a literal because its value self-evident. Because its value self-evident. Its value is self-evident, maybe? Every literal has a type, a form, and value of a literal determines its type. Yeah, I'll get the fuck out. You can write an integer literal using decimal, octal, hexadecimal notation. Integer literals begin with a 0 are interpreted as octal. Those that begin with either 0x or 0x are interpreted as hexadecimal. You can write the value 20 in any one of the following three ways: 20, 024, or 0x14. The type of an integer literal depends on its variant. Character and character string literals U, Unicode 16 character type char 16T. So a lowercase u indicates a Unicode 16 character, a big U, Unicode 32 character, L, wide character, U8, UTF-8 string literals only char. UTF-8. What is UTF-8? Integer literals, U or U unsigned, L or L long, LL or LL long long, F or F float, L or L long double. Okay. Okay, so literals cannot be negative. Character enclosed within single quotation marks is a literal of type char. 0 or more characters enclosed in a double quotation marks is string literal. Okay. And get what a string literal is. A string literal is what a dude bro would interpret as a string, right? But I don't get the difference between a string and a string literal, why they have to be different things. Because they're not, right? The type of string literal is an array of constant char. Yeah. We're gonna discuss that in part 3, chapter 5, section 4, page 122. That's in 60 pages, bro. The character appends a null character in every string literal, thus the actual size of string literal is one more than the apparent size. Okay. I get that. I'm just going to ignore the words string literal. I'm going to ignore the word literal, in fact, for this small position. Because what I've just read here is just the description of a string. People are going to be cringing at this, aren't they? They're going to be like, it's not a string, bro. You're wrong, bro. It's a string literal. Look, it says it in words. It does, but at the same time, that's what I was taught was a string, an array of chars. But then again, we had some fucking CS50.h bullshit going on in the background. And while that made it maybe easier to learn C, it also made it harder to learn C by the feel of it. It was a very relaxed and slow course with some interesting and difficult code to write. I'm almost certain I don't have the images to hand because it was all run on a virtual machine that you get given. It runs Linux, and I don't think I ever exported anything. And I've obviously reinstalled Windows a few times since then, so it's all gone. Some characters have no visual image. Such characters are non-printable. All good. Wait. Escape sequences are not part of the literal. This is so fucking. Who wrote this? Like, I get you need to learn this real quick, but. A vertical tab. What the fuck is a vertical tab? Apparently a question mark has to be escaped. I didn't know that. Oh, but it's used for referencing no, that's the percent sign. And that was basic as well. What the fuck am I so... Oh, God. I can't believe I started streaming so goddamn late. It's so stupid. This does not print tab followed by high and then a new line. It prints tab followed by high and then a new line. The quotation marks are not present. So a generalized escape sequence, which is \x followed by one or more hexadecimal digits, or a backslash followed by one or two or three octal digits. Value represented in the numerical value of the character. Some examples, assuming the Latin 1 character set: \7, bell, \12, new line, \40, blank, \0, no, hold on, \115, m, \x4d, also m. So that's using the escape value followed by, well, it can't just be the ASCII code. It's kind of weird how you can put characters in that way though. It's kind of fucked up. Alright. \x followed by one or more hexadecimal digits, right? Okay, so that's \x40, which is 4 16s, 40, 6 4s, 20, 64, D, 1, 6, 16, 10, no, 0 to 9, 10, 11, 12, 13, 64, 13, 73. 73 in the ASCII alphabet and M. I don't know. Does this tell me? If I go to my no. 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 It does not tell me. When you write a long literal, use the uppercase L. The lowercase l is too easily mistaken for the digit 1. God damn it. We can independently specify the sign-indebtedness and the size of an integral literal. If the suffix contains a u, then the literal has an unsigned type, so decimal, octal, hexadecimal literal with a u suffix as the smallest type of unsigned int. Okay, cool. Unsigned long, unsigned long, long. Okay, cool. We can combine u with l or ll to make unsigned long or unsigned long long, depending on whether its value fits in unsigned long. Cool. The words true and false are literals of type bool. Bool test equals false. The word nullpater is a pointer literal. We'll have more to say about pointers and a nullpater in Part 2, Chapter 3, Section 2, page 52. Oh. Hang on. Good. Good. Double excellent. Determine the type of each of the following literals. Explain the differences among the literals in each of the four examples. A is a character literal. LA is a wide character literal. A in quotation marks is a string literal. LA. Fuck. A wide character string literal? A string literal made of wide characters? Let me scroll up the chapter and read it again. I think it is. It doesn't say it's not, but it doesn't say anything actually about appending a string literal with a prefix. 10 is an int. 10 is an unsigned int. 10L is a long. 10 unsigned long. 0, 1, 2. That's a 10 written in octal. 0xc is 10. No, it's not. C. It's hexadecimal. So 9 and then A is 10. B and then C is 12, right? Fuck you. But that's just a hexadecimal int literal. 3.14 is a float literal. 3.14f is a float literal. 3.14l is a long literal. 10 is an int literal. 10u is an unsigned int literal. Is that a 0 or no? 10 dot. What the fuck? What is 10 dot? Scrolling back to the top of the chapter again. Oh, 10 dot is a floating point literal. I thought it was, but you never can be too sure. 10e to the 9 minus 2 is a 0.1 floating point literal. Int month equals 9d equals 7. Int month equals 0, 9d equals 0, 7. Ah, shit, there was something about ints beginning with zeros. But I can't remember. Here we go. We can write an integer literal using decimal, octal, hexadecimal. Integerals that begin with a 0 are interpreted as octal, so it's written in octal. And that means that the 9 is going to be undefined, maybe? Because I'm guessing I can only assume that octal deals with 8s. 9 is obviously not an 8. So it would be actually 0, 1, 0, 0, 7. Probably wouldn't do the conversion for you, so it probably wouldn't work. What do these literals represent? What types does each have? Who goes with F backslash 145 RGUS backslash 012? Okay, so it's a string literal which includes an escaped character E, I'm assuming, lowercase e, and new line 012. Yeah, new line. .14 E1L. It's a long literal scroll back up and here we go. 20 to 3F. Single precision floating point literal type is float. A single precision floating point long. The fuck's the point? Why would you do that? Where am I? No, I've gone too far. .1024F is a float, and 3.14L is a long. Using escape sequences, write a program to print 2M, followed by a new line. Modify the program to print 2, and then a tab, then an M, followed by a new line. Okay. Do I have to? I don't really want to, but it's something for you to look at. Wham. What's the escape character for 2? What's the escape character for an M? 115. Can I just do that? The fuck is that? The fuck is that? It's a question mark in a small square. Okay. It's obviously not gonna work. X2 maybe. That is the same question mark in a small square. Excuse me while I boot up my web browser. Oh, check it out. I have we're here right now. It's technically Tuesday, but it's mine. This is my Monday still. I've got a stream selection. I've got a new tab for my VOD button because they changed the background color, and I didn't notice for a long time. And then I noticed, and then it bothered me, and then it bothered me enough to change it. It's ASCII escape. Thank you for not typing ASCII 2 character. Char. Extended ASCII codes. Okay, no, char. Hold on. That's a whole bunch of no. Here we go. 2062. That was a fucking. It's a picture, guys. Oh, you can't see that. Let's run that. 2M. Excellent. Yeah, so when you escape, you can just type in an ASCII number. We got start a heading, start a text, then a transmission inquiry. Oh, EOT. Oh, we can just send those. 004 oct. X4 hex. Nice. What was 2? Start of text. Okay, so the box, the question mark in the box is start of text, which is okay. Okay. Medium cancel, end of trans block, synchronous idle, negative acknowledge, carriage return, shift out, shift in. Wait, wasn't the tab a character on its own? As a vertical tab, we would like a horizontal tab is \T. Why wouldn't it be \T? You can just jam these all together like some kind of madman. I would like to actually see what a vertical tab looks like, because it just sounds mental. Vertical fucking tab. Yeah, that's what I fucking thought it would do. Use the right one, yeah, \V. Insanity. We have extended ASCII codes here. Have some beard noise though. Brackets, gradient halftones, 192, 193, 194. Your 194 is full, 193 is less than full, 192 is less than full. There's a whole bunch. There's an Omega 250. It's Omega. Oh, but it wants you to look up the hex and the oct for these characters yourself. It only gives you the int. A lot of French characters. No German double S. No Cyrillic. End of file. Thank you. So that would all be done in extended character sets Unicode. Variables. Int 0 value, unit sold 0, sales item. Oh, I'm not going back to that. Stupid. Object that is initialized gets the specified value at the moment it's created. Good. And this is variables. Initialization is not assignment. Initialization happens when a variable is given a value when it is created. Assignment obliterates the object's current value and replaces that value with a new one. Good. What's that noise? What is that fucking noise? Who knows? Generalized use of curly braces for initialization was introduced. Part of the new standards. What? Several different forms of initialization in the following 4 different ways to define an int variable. Unit sold equal int unit sold equals 0. Int unit sold equals curly braces 0 curly braces. Int unit sold curly braces 0. Int unit sold brackets 0. Okay. List initialization. Okay. Int a1d b equals 1d c equals 1d 1d equals 1d. Long double long double ld equals 3.14 blah blah blah. Int a1d in curly braces comma b equals curly braces 1d. Error narrowing conversion required. Int c brackets ld d equals ld. Okay, variable truncated. Okay, it's fine. Compiler rejects the initializations of a and b because using a long double to initialize an int is likely to lose data. At a minimum, the fractional part of ld will be truncated. In addition, the integer part in ld might be too large to fit in an int. As presented here, the distinction might seem trivial after all, and unlikely to directly initialize an int from a long double. However, we'll see in chapter 16. Christ knows what page that is. Page 84, 98. Really? Cool. Most classes let us define objects. Each can wait, hang on, I've skipped a whole bunch. I just fucking phased out. Default initialization. When we define a variable without initializing, the variable is default initialized. Such variables are given the default value. Whatever the default value is depends on the type of the variable, minus depend whether the variable is defined. Variable is an object of built-in type, not explicitly initialized events aren't aware it is defined. If variables defined outside any function body are initialized to 0, with one exception we cover in 6.1. Variables built-in type defined inside a function are uninitialized. The value of an uninitialized variable of built-in type is undefined. It's an error to copy or otherwise try to access the value of a variable whose value is undefined. Good. The class controls how we initialize objects in the class type. Protecting us up to the class we can define objects in that type without an initialize. If we can, the class determines which the value its resulting object will have. Most classes let us define objects. Okay, we're talking about classes now. The library string class says we do not need to supply initialize. The resulting string is the empty string. Okay. Standard empty string. Cool. Explain the following definitions for those that are illegal. Explain what's wrong and how to correct it. Standard cn int input value. Int I equals 3.14 in curly braces. Seems fine. Double salary equals wage equals 9999.99. Can't do that. That's ridiculous. You can have double salary comma wage equals 9999.99, right? Int I equals 3.14. That's kind of okay. I worry about the standard. Oh, int I equals 3.14 in curly braces is illegal as well because it will have the narrowing exception, which means it will the program will freak out about having to fit the giant size of a 3 inside an int, and it also doesn't want to truncate. Okay, so yeah. What are the initial values, if any, following? Standard string, global string, empty string, so no characters and then a null character. Int global int 0, int main, int local, int standard string, local string, undefined, undefined. It's talking about how C can be written in separate files. Good, like header files. Source files are class files. Class definition files. Oh boy. Spot separate compilation C++ distinguishes between declarations and definitions. Declaration makes a name known to the program. A file wants to use the name defined elsewhere, includes a declaration for that name. A definition creates the associated entity. Cool. Variable declaration specifies the type and name of a variable. A variable definition is a declaration in addition to specifying the name and type. A definition also allocates storage. Might provide the variable initial value. Oh. Extern int I declares but does not define I. Int j declares and defines j. Any declaration that includes an explicit initializer in its definition, we can provide what? Initializer on variable defined as extern, but doing so overrides the extern an extern that has an initializer is a definition. What? Am I too tired to fucking read now? Any declaration that includes an explicit initializer is a definition. We can provide an initializer on a variable defined as extern, but doing so overrides the extern. An extern as an initializer is a definition. Any declaration that includes an explicit initializer is a definition. We can provide an initializer on a variable defined as extern, but doing so overrides the extern. This is fun. I've read it 4 times now and it does not make sense. What the fuck? Oh right, I've missed a chat. I've missed a 3 paragraphs. Okay, no. Variable declaration specifies the type and name of variable. Variable definition is a declaration. A definitional value storage and may provide the variable with initial value. Do that. To obtain a declaration that is not also a definition, we add the extern keyword and may not provide an explicit initializer. Any declaration that includes an explicit initializer is a definition. We can provide an initializer on a variable defined as extern, but doing so overrides the extern. An extern that has no initializer is a definition. I get it. Yep. That one sentence just brought it all together. It is an error to provide an initializer on an extern inside a function. Very obscure book. Thank you for pointing that out. Explain whether each of the following is a declaration or a definition. Extern int ix equals 1024. That's a definition. Int iy is a definition. Extern int iz is a declaration. Typing, statically typed, does not mean typed. It means the types of things. Identifiers in C++ can be composed of lots of digits. The underscore character language imposes no limit on name length. Identifiers must begin with either a letter or an underscore. Identifiers are case sensitive. Upper and lower case characters are distinct. Identifiers are the name of variables. Okay. You can use an underscore or an alpha character to begin. You cannot use a line S, a line of, ASM, auto, bool, break, case, catch, char 16t, char 32t, class, const express, const cast, continue, call type, default, delete, do, double, dynamic cast, oh god, else, enumerate, enum, explicit, export, extern, false float, for, friend, go to, if, inline, int, long, mutable, namespace, new, no, except, null pointer, operator, private, protected, public, register, reinterpret, underscore cast, return, short, sign, size off, static, static underscore assert, static underscore cast, struct, switch, template, this, thread local, throw, true, try, type def, type ID, type name, union, unsigned, using, virtual, void, volatile wchar underscore t while because they're already in use by the C core programming, bro. They're all already function names or internal names for stuff that you can use leverage in the C. Alternative operator names and bit and compol not eek or eek sorik and eek bit or not or sor not or and bit and oh right, you can't use those either. Okay. Oh. Now part that USB-C cable I had. I have to use it now. Engaged. Standard also reserves a set of names for use in the standard library that identifies can't use two consecutive underscores, nor can identify begin with an underscore followed immediately by an uppercase letter. Lame. In addition, identifiers defined outside a function may not begin with an underscore. Okay. Conventions for variable names. Variable names are normally lowercase, index, not index or index. An identifier should give some indication of its meaning. Yeah, cool. Like sales item, classes we define usually begin with an uppercase letter. Identifiers with multiple words visually distinguish each word. For example, student underscore loan or student capital L loan, not student loan. Which, if any, of the following names are valid? Int double equals 3.14. Fine. Int underscore. I feel like you can't do that. But it's not on the lists. It's not two underscores followed by a capital letter. Sorry, it's not two underscores together, and it's not an underscore followed by a capital letter, so it's fine. Int catch dash 22 illegal. Int 1 underscore or underscore 2 illegal. Double illegal. Wait, is it illegal? No, it's distinct from double, but it's a bad idea. Yeah, double is all lowercase. Double with a capital D is fine, but it's not advised. Scope is a part of the program in which a name has a particular meaning. Most scopes in C++ are delimited by curly braces. The same name can refer to different entities in different scopes. Names are visible from the point where they are declared until the end of the scope in which the declaration appears. Okay. Cool. Nested scopes. Scopes can contain other scopes. Good. Yeah, curly braces inside curly braces. Things inside the curly braces can see things outside the first set of curly braces. Things outside the second set of curly braces cannot reference things initialized and used inside the second set of curly braces, right? Yeah. Int reused equals 42 in main void. Reused as global scope. Holy shit. You can use it fucking anywhere. Let's go. What is the value of j in the following program? Int I equals 42 in main brackets. Int I equals 100. Int j equals I. 100, 100, 100, 100. Is the following program legal? If so, what values? What the values printed? Int I equals 100, sum equals 0. For int I equals 0, I does not equal 10, plus I, sum plus equals I. Does that work? Can you put a does not equal into a for loop? I don't know. If you can, it's fine. And it sums. But so it's 100 plus 101. So it sums to 100, 201, 303, 405, 610, no, 510. Brain seeping from head. Can I clear? $1,045. No, compound type. This is new, but do I dare? Okay, this is some heavy stuff. So we are going to stop at chapter 2.3, compound types, because that's complicated. It scared me off. I mean, I'm just not really. My brain's slow down. We've been up for an hour and 35. It's good enough. That's long. It's a unhealthily long time to read or study for. In fact, you should take frequent breaks when you're trying to learn stuff. But I feel like I've learned something, and I've completely forgotten what it was. Unsigned types. That's right. Unsigned types loop through their maximum value range. If they exceed their maximum value range limits, they can't be negative. I'm sure there's something else. Oh, you can append type literals to specify stuff. Like the precision of floats. You can specify using a certain type of float when working with decimal values. You can escape ASCII characters into your text using backslashes. I think that's most of the stuff that we covered today. I know we just covered declarations and definitions. Probably gonna read that over again sometime in the week before next Monday or Tuesday morning, as it would probably be. But yeah, thanks for watching the live video. If you came for a live video, man, I'm tired. Ooh, we are definitely gonna do an Unreal segment though after this. Thanks for watching the VOD. If you can watch the VOD, and as always, or not as always, in fact, I'm not gonna stop streaming. I'm gonna mute my mic. I'm gonna go away. I'm gonna stop recording, and I'll start recording when I come back. Oh, what can you see there? Droop. Yeah, okay, it's my desktop. Please don't look at my Epic Games launcher, no. That's gonna be like, oh shit. Bruh. We'll get it later. I'm still not on 421. I mean 424. Bobble Man. We'll load this up. We'll get it on screen.